11.2 notes. Now, if you're looking for this video on my website, you may find last year's 11.2 notes from fall 2017. And I just wanted to let you know the main difference for these notes to those notes is those notes have different examples here. So if you want to see some more examples of how these different properties work, that would be a great place to go, is to look at my 11.2 notes video from last year, because it'll give you some more examples here. Okay? So, again, we are getting into fractional exponents and what do you do with those. And what this page is it shows a bunch of properties of exponents that you already know how to use. And I'm just going to show you how they still apply even when you have fractional exponents. So let me start with this first property. Sorry. The first property is called the product of powers. Now before I get into that too far, I want to define the word powers for you. Okay? You have seen powers before in something that looks like this. Now this whole thing together is called a power. Okay, the power is made up of two parts. It is made up of a base and it is made up of an exponent. So that's where our power comes from. So the product of powers simply means I have two of these things being multiplied, such as right here. I have 5 to the 1/2 times 5 to the 3/2. Now when you did it with numbers, not with fractions, with nice numbers I should say, you would have like 2 to the 3rd times 2 to the 2nd, and you would add your exponents. So what we're going to do here with our fractional exponents is we are still going to add our exponents. And 1/2 plus 3/2 is what? 4/2, which reduces to 2. So this ends up becoming 5 to the 2nd, which is 25. So it works with our fractional exponents. Now, with radicals, we can do two different things. We can either change them to exponential form, in which case they give us this, or we can go ahead and add our exponents still. 1 plus 3 means my new exponent is a 4. And the square root of 5 to the 4th would be 5 to the 4/2, which is 5 squared, or 25. Another way to think about that is 5 to the 4th is 5 times 5 times 5 times 5. So if I think about who can come out with a second root or a square root, that means I have one 5 on the outside. That means I have one more 5 on the outside. Nobody's left inside, and 5 times 5 gives me that 25. So there's a couple different ways you can think about that one. Okay? Next property is the power of a power. So we're going to start off with a power, and we're going to raise it to another exponent. This is the way you would have seen it with numbers. And all it's saying is that when you have an exponent out here, you're going to multiply it by the exponent that's already there. Keep in mind, these are the two most often confused with each other. And the main thing that I noticed that is hopefully will help you separate the two is this one, your base is listed twice. If your base is listed twice, you're adding those exponents. This one, your base is only listed once, and then you have two exponents. If you are distributing an exponent to something that already has an exponent, then guess what? You're going to be multiplying it. So this one, if I were to simplify this, this would be 3 to the 5/3 times 3. And if you went to your calculator, which again is in my drawer here, 5/3 times 3, if you don't know that in your head, go ahead and use your fraction button. 5/3 times 3 is just 5. That gives me 3 to the 5th power. And if I want to know what 3 to the 5th power is, I come to my calculator, it's 243. All right, what if I had 16m to the 8th to the 1/4? Well, I've got two things going on. I have the 16 and I have m to the 8th. So the 16 has to get the 1/4. That gives me 16 to the 1/4. And the m to the 8th has to get the 1/4. Now, since m already has an exponent, and I'm distributing something else that's an exponent, notice the base is only listed once, I'm going to need to multiply 8 times 1/4. Okay, now 16 to the 1/4, I can simplify that. That is the 4th root of 16, or I can go to my calculator and go 16 to the parentheses 1/4 power, and the answer is 2. Okay, sorry about that little interruption. So I have 2, which is my result from 16 to the 1/4 power, and then I'm going to have an m, and I just need to multiply 8 times 1/4. So 8 times 1/4 is also 2. So my new exponent is also a 2. That would be my solution there. Okay. Let's see. In radical form, here's what I would do. What happens when you cube a cube root? Well, as long as that exponent matches the cube root, it's going to cancel that, leaving me with just 3 to the 5th. Now that only works if I'm cubing a cube root. If I was raising a cube root to the 4th, then I got to change it to exponential form and do some things there. But here it gives me 3 to the 5th, and I already did that one. That's 243. Same as this, just written in radical form. This one written in radical form, this one actually uses the next property as well. What I would do is, if I have the 4th root, I would call this the 4th root of 16 times the 4th root of m to the 8th. Now you can find the 4th root of 16. You can also think about it as the 4th root of 2 to the 4th. And again, that index cancels out, leaving you with a 2. And then the 4th root of m to the 8th, well, that's the 4th root of m to the 4th times the 4th root of m to the 4th, right? I can split up m to the 8th into 4 and 4 because those two would be added. This is kind of a confusing way to do it. But it cancels out, leaving me with 2 m's, so I would have m squared. Truthfully, I think it would be easier to leave that one in exponential form, or even to change it to exponential form from there. Call it 16 to the 1/4 and m to the 8/4, and just go from there. I think that would be simpler. Okay? All right, power of a product. I kind of used that already. When you have a product, meaning two things in there, you're going to have to take that exponent and apply it to both parts of it, which I just did right there. So this would be 16 to the 1/2 and x squared to the 1/2. Well, 1/2 we should remember is a square root. If you don't remember, you can go to your calculator and plug in 16 to the 1/2. It'll give you 4. And x, 2 times 1/2, this is going to be multiplication, and 2 times 1/2 is 1. And we don't need to write an exponent of 1, so I just get 4x. Okay, doing that one in radical form, that would be the square root of 16 times the square root of x squared. Well, square root of 16 we know is 4. Square root of x squared, those two would cancel, leaving you with your x right there. Okay. Now, she has it written here as kind of with plain numbers, but this is kind of to show you that you can go backwards with this also. A way to more simply do this, if you notice, since they have matching exponents, you can actually kind of undistribute that exponent just to make your problem a little bit simpler. And you can go ahead and multiply the 4 times the 3, which would give you a 12 to the 5th power, rather than calculating 4 to the 5th and 3 to the 5th and then multiplying those. 12 to the 5th, 12 to the 5th, going to your calculator, is a very large number. It is 248,832. In other words, 248,832,000. When you're dealing with powers, you're bound to get some big numbers there. Okay, this is very similar. 12 to the 1/3. I can call this the cube root of 12 times 18. It's a similar process to that. And 12 times 18 in my calculator, 12 times 18 is 216. And the cube root of 216, if you don't know it, you can find it here. Oops, 216 is 6. So again, there's a simple way to find that one. All right, from there, we've got negative exponents. We can't leave negative exponents in our answers. Negative exponents are Not so fun. If we have a negative exponent, if it's just by itself, we need to assume that it's over 1, because all numbers are over 1, unless they're written differently. And then we would take that a to the negative power and we would move it to the bottom, and that's what makes it positive. Now, the opposite is also true. If you have a negative exponent on the bottom, it moves to the top of a fraction to become positive. So please don't say that you are just flipping a fraction. You are not flipping a fraction. You are simply moving whatever has a negative exponent to the opposite side of the fraction. So this is not written as a fraction. Since it has a negative exponent, I must write it as a fraction. So it's going to be over 1, which means I'm going to take the 25 to the negative 1/2 and move it to the bottom in order to make that exponent positive. Now, I am not just flipping this fraction, however, it might look like that because I'm going to put a 1 here. Why am I going to put a 1 there? Because there's nothing left, I have to fill in a 1. Okay? And we know that 25 to the 1/2 power, or is the same way as saying the square root of 25, which is 5. And that should be my result right there. Okay? Let's see. You can't have a negative on your index right there. So you would just leave this right here as the square root of 25 to the negative 1. You would call that, you would simplify the square root, which you know is 5. Raise that to the negative first power, and that gives you 1 over 5 as your answer. Another way of showing that one just in radical form. Okay? All right, now we're going to get something like this. We may see several problems like this. This one is already written as a fraction, so I'm going to leave it as a fraction. I'm going to start off by looking at just those two numbers, 3 over 12. What does 3 over 12 reduce to? 3 over 12 reduces to 1/4. So I have a 1 on top and a 4 on the bottom. Now, I have an m on top, but it has a negative exponent. So does he get to stay on top, or does he need to move to the bottom? He needs to move to the bottom to make that exponent positive. Okay? So I've dealt with everything on the top. What about this x on bottom? Positive exponent or negative exponent? Positive. It's just to the first power, so he can stay on the bottom. And then finally, this guy right here has a negative exponent. He's currently on the bottom, so where does he need to move to? The top. And then his exponent becomes positive. Now, do I need to write a 1 on top? Only if there's nothing else up there, like there was, where was it, right here? But since I have the y, I don't really need the 1. I could just leave it as y to the 2/3 over 4m squared x. Okay? All right, 0 exponent. Anything to the 0 power is equal to 1. Biggest mistake there is when people say anything to the 0 power is equal to 0. That is not true. It's anything to the 0 power equals 1. So let's see what we get here. If I have, notice I have my base listed 3 times. I said if my base is listed more than once, we're talking about this power product of powers property. So we're going to be adding those exponents. So in other words, I can call this 5 to the 2/3 plus 1/3 plus negative 1. That's all in that exponent. I'm going to go to my calculator. 2/3 plus 1/3 plus negative 1 gives me 0. So that's really 5 to the 0 power, and anything to the 0 power equals 1. Now, the one exception to that is if I have something like this, and it's not really an exception. This is not in, well, let me show you this right here. If I had negative 5 to the 0, that means the whole thing is to the 0. The negative sign, technically negative 1 times 5, would be negative 1 to the 0, and 5 to the 0, which is 1 times 1, which is 1. But if that negative is not in parentheses, then guess what? This is equal to 1, but that negative sign stays out front still. That's the only time is when it's not in parentheses there. Okay? All right. You cannot have a 0 index number or a 0 denominator for fractional exponents. Those should be self-explanatory. All right, quotient of powers. If I have bases that match and they are written on either side of a fraction, then guess what? we take our exponents and we subtract them. So here I have matching bases. So I would take the top exponent and I would subtract the bottom exponent. Top exponent is what? Well, there isn't one written, so it's assumed that it is a 1. And then the bottom exponent is 1/3. Well, 1 minus 1/3 is, you can go to your calculator if you need to, 2/3. So I have 5 to the 2/3 power. Okay. Much easier to find with online roots, blah, blah, blah. Okay. Next one, power of a quotient. Well, if you have a fraction with an exponent, guess what? That exponent has to go to both the top and the bottom. Now, this example kind of uses this rule and this rule up here because I have more than one thing on the top. So pretty much everything's got to get that 1/2 power. I have to have 12 to the 1/2. I have to have m to the 1/2. And I have to have 25 to the 1/2. And if there was more than just the 25 on the bottom, every part of the bottom would also get that 1/2 power. Okay? So, let's see. I have 12 to the 1/2, which I'm going to leave like that. M to the 1/2, not much I can do with that. On the bottom, 25 to the 1/2, we know that is the square root of 25, which is just 5. Yeah? And let's see. So something I notice about this 12 to the 1/2, we know that a 1/2 is a square root, correct? So if I have the square root of 12, that can be simplified, can it? I can take out, let's see, that breaks down to 3 and 4, 2 and 2. That actually becomes what? It becomes 2 radical 3. So I actually need to simplify that. So I have a 2, but the 3 is still under the radical, so that would be represented like that. The 3 still has the 1/2, the 2 does not. The m, he still's got the 1/2, can't do anything with that. And then I have a 5. That one's just a really not pretty answer. Okay? All right. Square root here, same kind of thing. Square root of 12m over square root of 25. We know the square root of 25 is 5. Square root of 12m, we would draw our tree for 12. We would take out our 2, but inside we have to leave a 3 and that m because he has no partners to leave with him, so it's just like that. That one's actually prettier in that form than it is in exponential form. Okay? All right, so let's see what I've got here. This is pretty ugly. However, I notice they both have that 4th root, which means that I can combine them both under the same 4th root. Why is that beneficial to me? Well, it's beneficial to me because I can simplify in here and then worry about my 4th root. I can do 80 divided by 5. What is 80 divided by 5? It's 16. So I have the 4th root of 16. And x to the 9th over x to the 5th, I can use my subtraction rule. That gives me x to the 4th. So if I split this up, 4th root of 16 times the 4th root of x to the 4th, well, what's the 4th root of 16? 4th root of 16 is 2. And then 4th root of x to the 4th is going to cancel and leave me with just an x. So that simplifies all to 2x very nicely. Okay. All right, let's turn the page. We have a couple more examples here. Just want to make sure that you have everything you need here. Let's see. So, right here, I have radicals, but they don't have matching indexes. Do you see that? This one has an index of 2, and this one has an index of 3. But I do see that I have common bases. So what I'm going to do there is I'm going to go ahead and change this to exponential form. This would be x to the 3 over, the index there is a 2. And then down here, this would be x to the 2 over 3. Because if I have the matching bases, then I can subtract my exponents. So the top exponent, 3/2, minus the bottom exponent of 2/3. Let me go to my calculator. 3/2 minus 2/3 gives me 5/6. So my answer is x to the 5/6. Now, just to be clear, that's on the top of a fraction. What would happen if I did my subtraction and I ended up with x to the negative 5/6? Well, that's still on the top of a fraction, but I couldn't leave it like that. I would have to put it on the bottom, x to the 5/6. If I had a negative exponent, I would have to move it to the bottom to get a positive exponent. Okay? That wasn't our case, that's just what you would do in that case. All right, let's see. These are just different ways of doing this one, I think. Actually, I think these are supposed to be different problems. I'm going to change this one. This I'm going to change because this is the exact same problem that's written there. Let's call this the 6th root of 16 cubed times the 4th root of 4 to the 6th times the cube root of 8 squared. Okay, so I have different indexes and different bases. So I'm going to go to exponential form and see what we can do. This would be 16 to the 3/6, which ends up being 16 to the 1/2. What do we know about 16 to the 1/2? It's the square root of 16, which is what? It's 4. All right, next one. This would be 4 to the 6/4, which if I reduce that is 4 to the 3/2. That's not your bell, just so you know. It's just a bell in the video. And 4 to the 3/2, I think 3/2 is a nice number. It's 8. And then finally over here, this would be 8 to the 2/3. Well, I can do that one in my calculator too. 8 to the 2/3 is 4. That whole thing, those simplify to 4 times 8 times 4. 4 times 8 times 4 is 128 as my answer. Okay. All right, last example. I'm going to change this one. It's going to be the square root of 64y over the cube root of 64y. Now, I see 64y and 64y, and everything in me wants to just cancel the 64y's. But I can't. Why not? Because, so since the index up here is a 2 and the index down here is a 3, I actually have to go to exponent form. So I have 64y. It's in parentheses because the whole thing is under the radical. Square root is an exponent of 1/2. On the bottom, I have 64y. Cube root would be to the 1/3. So let's do some distributing. This has to apply to both parts. So that's 64 to the 1/2, y to the 1/2. On the bottom, I have 64 to the 1/3 and y to the 1/3. So, what is 64 to the 1/2? Isn't that the square root of 64? Which is what? 8. Y to the 1/2 I'll deal with in a few minutes. 64 to the 1/3, which is the cube root of 64. Do we know what the cube root of 64 is? Yes, it's 4. And then y to the 1/3. So now let's continue simplifying. 8 over 4, I know that becomes a 2. Now I have two y's, the bases match, so what am I going to do with the exponents? Same thing I did over here, I'm going to subtract them. So 1/2 minus 1/3, it's always the top exponent, minus the bottom exponent. What is 1/2 minus 1/3? 1/2 minus 1/3 is 1/6. So I have 2y to the 1/6. Okay. All right. Good luck with that. Your homework is a textbook assignment. However, it is posted on Google Classroom, so you can go there to find your problems as well as the odd answers. Happy studying.